We're now recording the meeting. So this is my presentation today. I'm going to be talking about gate troubleshooting a little bit. Because I work on Ironic, I'm going to focus on Ironic a little bit, but the general patterns that I'm talking about should be applicable to many different groups or users. One thing I am going to point out is that while I have a small number of examples I'm going to go over as I'm teaching this, if you have a patch right now that is failing the gate and you can't figure it out, or you think it represents an interesting failure, put it in the group chat or send it to me in IRC right now, and if we have time later, sort of maybe instead of typical questions, we would take interesting gate failures instead and debug them together. No promises we'll get to the bottom of them, but you'll be able to see the process used live on gate failures that I haven't hand-picked and already know how to fix them, which obviously makes my job a little bit easier this time around. So the first thing I sort of just want to talk about is why it's important to be aware of and be on top of gate failures. I'll scope the talk first. When I talk about gate failures, yes, there are unit tests. Yes, there are PEP8 that runs. But I'm mainly going to be talking about the DevStack jobs that run with Tempest against them, or the grenade jobs, mainly because those are the ones that are most difficult to troubleshoot. I think most of us at some point have had to troubleshoot a PEP8 failure or a unit test failure or something like that. And troubleshooting those in the gate is obviously the same as you would locally, so I'm not going to dig into that. I will show you a trick about docs troubleshooting in the gate, but mostly this will be focused on gate tests and gate jobs. And no, there are not slides. I do not believe in slides, and slides are not necessary for OSIC Tech Talks. I'll be sharing some web browser with you here shortly. So let's get started. This is a very loosely arranged talk. If you have a question or you'd like to ask something or for me to go in detail about something, just go ahead and unmute yourself and ask, and we'll get it going. So first of all, this is a failing one, but I'm going to show you a couple of quick things. And the first of all was I told you that there is a good trick you can use for docs. And this is something that surprisingly a lot of people don't know. But if you hit right there on the Gate Python Ironic Client docs Ubuntu Xennial, it does not actually take you to the log messages from where this is generated. It actually takes you to the generated draft documentation. So this means if you're ever reviewing something that has a docs change in it, you can go ahead and hit that docs link and dig in and look at how it renders. And this is really important because RST formatting is pretty finicky, and it doesn't always come out like you say. So I know not everyone knows about that trick. I figured I'd toss that out there so that folks do know. But let's talk about the actual failures. In this case, this is a Python Ironic client test, and there's a few things on this screen in particular that I want to point out that are useful to think about when you're troubleshooting the gate or when you're looking at a patch in general. The first is the branch. That it's a good idea to not always assume you're dealing with master, because a lot of these patches are not going to be against master. They're going to be stable or whatever, and so you have to adjust your troubleshooting mindset appropriately. Another thing I'll point out is this toggle CI button at the bottom. What you're seeing right now is the view where all of the CI comments are completely collapsed away and summarized up here. So this means if you've got a patch that has multiple patch sets, or that has had multiple runs of CI against it, you can't see all those results. But if you hit this toggle CI button down here at the bottom left, it will actually take that. There we go. It will actually take that, and it'll re-add the comments. So you see here it's only run once, but you get the actual comment from Jenkins. And on a job that's run quite a bit more, as you can see here, you see there are comments from Jenkins all the way through for each patch set that it runs on, each time that it runs, and those logs are accessible, I believe, for up to 30 days. Maybe more, actually. I should have looked that up before the test, but for the test, for the presentation. But you can see hitting that toggle CI button is almost always the first thing I do when troubleshooting a gate failure, so that I can ascertain, has it failed before on this patch set? Has it changed over the course? Like, you know, has Tempest, for instance, ever passed against a version of this patch? And oftentimes, looking at the logs, even in the case of a success on an earlier build, will maybe show you a warning or something that's useful to troubleshooting it later. And that goes in general. I strongly encourage you, for whatever the project is you work on, go find a job that is passing everything and go just have a look. Go dig around in the logs a little bit, and you should have a feel for what like a good test run looks like for your project. Because if you haven't looked at it, you might gloss over a warning and think that it's normal and maybe it's not, or maybe even vice versa, end up chasing down a rabbit hole for a deprecation message that's printed on every patch that's merged this cycle. So definitely start with that baseline. But let's troubleshoot here. So this patch is one that was uploaded to Stable Okada yesterday in order to prepare it for release, because we've released our Okada Ironic client and we've got to go for it now. But as you see, it's failing functional tests. So we're going to troubleshoot why it's failing functional tests as our first example. And as I showed you with the docs, you just click this and it'll take you to a link that'll summarize what's going on. Now, I will call out this little Zool Ansible directory here. You typically don't have to look in here, but in there contains all of the deployment automation that was used by the gate to provision this node. It's not typically something you need to worry about. But if you see a situation where, for instance, you can't see how something failed in the logs, or maybe even I've found situations where at the very bottom it'll say exit code 0, but it'll still say that Zool returned failure. You can sometimes read through those Zool Ansible logs and figure out why that happened. If you don't know Ansible, it might not mean a lot to you, but that's sort of a place that you kind of go to meta troubleshoot, right? Like if there's something wrong with Zool Ansible causing your job to fail, then something's wrong with the job configuration or infrastructure or something that's likely unrelated to your patch. So we also have this console.html in the logs. The console.html is where I always start. There are sometimes potentially better places to start, but I like starting here on the console.html. So I'm going to hit the console.html, and you see here, and typically you read web pages from the top down. Don't read web pages from the top down in the gate. Wait for it to load and hit your friendly handy-dandy end key and go to the very end of the file, and you'll read it from the bottom up. This is because this is just a typical log file. You've got the later entries at the bottom, and almost always whatever caused it to fail is closer to the bottom. You can scroll up and find it. And here you can already see that we've got errors abounding. And so let's scroll up and let's see initially what it was that's failing when it errors out. You see it errored running functional, and it's got this functional one.log that we can look at if we need to. Now look and see what happened. It was running tox install, and it passed it this URL to get the upper constraints file for Stable Okada and some of these arguments. And I'm not going to look at the environment, but then we're going to come down here and look. And we're going to see that it's got a trace back, and it says invalid requirement, open bracket bang doc type HTML. Well, that doesn't look like a requirements file to me. And you can see that's also where it is tracing back, is that it failed parsing it. So I'm wondering what's the deal with the requirements. So let's go have a look then, for instance, at this upper constraints.txt URL, which is actually what this patch was changing. And I'm just going to open this up in a new tab. And you can see this is why it's failing. Because instead of getting a requirements file like we were expecting, we get an error message from Git. And what I did to further troubleshoot this is I just went over to GitHub and I opened up OpenStack requirements. And if you look here, you can hit the button and see what branches it has. And as you can see, it hasn't yet branched for Okada. So these automatic patches, which are pulling in Stable Okada requirements, are what's causing it to fail. And this is sort of, I'm going to call this a best case failure. And why do I say that? Because it's really easy to troubleshoot. Everything you need is in the console.html. We didn't have to go to any other log file. We didn't have to go to anything else. Just went from the console.html, and literally upon moving up, the error was the first thing we saw. So this is a very, very obvious one. It failed while it was setting up. And so we don't have to get that deep into troubleshooting to figure out what happened in this case. And in this case also, you can see as that URL is literally the only thing that changed in this patch, that the patch itself is what's causing the error, which means this isn't some sort of systematic gate problem. This is a problem with the patch that hopefully will be resolved once the requirements project also branches for Okada. Does that sort of make sense to everyone? So that's the super easy one, training wheels. Let's bump it up a notch. And this is an ironic Python agent patch that had a failure that is sometimes one that you would see very often in ironic Python agent or in ironic jobs in general, but not quite as often for non-ironic jobs. So following the pattern of what I suggested before, let's look at a successful one, and let's see what these logs look like. First of all, the first thing that you'll notice that is different about this, that is useful, is that because this is a typical Tempest job, we actually get the help text right here. This help text is great, and it has some good advice. Like you can see, scroll to the end of console.html, work your way backwards until you find a failing test. So it's basically what I just told you, which is great. And it will also identify for you when you get into a log subdirectory what each log does, which is very useful if you haven't been that experienced with it. So let's look at this. This, like I said, is a passing run. So let's look at what is sort of normal for this. Again, opening up the console.html. Once it loads, hitting the end key. And you can see here at the bottom, and this is something you'll see in almost every passing job, that the task exit code was 0 and result is success. If you ever see that the task exit code is 0 and somehow it doesn't result in success, that's one of those cases where maybe reading the Zool Ansible logs will help you trouble, or the Zool Ansible code that's up there for spinning this up may be useful. But that's usually caused by an infrastructure issue, because if your job exits 0 and it doesn't return a success, then what are you doing, you know? So, and you can sort of see an idea here of what this looks like in a best case scenario. You don't see a lot of traceback. You see a lot of Tempest tests going, okay, okay. Right, so you know what this looks like. It's nice, it's clean, it's got good output. And you can see it took about 472 seconds for that Tempest run. It was useful information to know. That's also something you'll pick up over time, is that you can glean some information oftentimes by looking at the time stamps here beside the failure. So you can see how long it took for it to fail. And that often can be a good clue into why the job might have failed the more often you look at it. So in this case, like I said, it's a successful build. We can go look at the dev stack log if we want. Most of you have seen this before because this is what prints out of stack.sh when you run it. And again, hit the end key, go to the bottom. In this file, if you see the dev stack has ended properly, most likely stuff has gone well. One thing of note for people working on Ironic is if you're looking at an Ironic Python agent source job, which is what this is, the dev stack log is where all the output is regarding building the agent image. So if you have a situation where you're troubleshooting an Ironic Python agent patch and you see it failed because of DevStack didn't start up properly, you can look in that DevStack log, and many, many times it is an error while building the agent RAM disk. Those failures happen a lot more often in Ironic Agent than they do in other projects because the infrastructure teams work really hard to do things like mirror Git repositories and package repositories, but that work has not been ported into work for our agent RAM disks build. So we sort of, from the start, have a little bit more of a chance of a random network failure or something breaking. But you also see here with a working one that you have all of these screen files. And what these are is these are logs from the processes that are running inside the test DevStack cloud. And you can look down here and you can see it actually will identify exactly what each log does, which is super useful, especially for things like Neutron, because it says Q in the name. And unless you've been working on OpenStack for 3 or 4 years plus, you probably have no idea whatsoever what the Q is. And it's Quantum. It's what Neutron used to be called, and they never changed the abbreviation in DevStack because it would have conflicted with Nova. So you sort of get the idea here that some of this is not always so easy to grok. I think with newer services, like in this case Ceilometer, you can see some example of where they're expanding it. But Ironic is IR still, as well as the Ironic BM logs. The Ironic BM logs are another useful thing if you're working on Ironic. You get the output from the node consoles that booted, and these are the virtual bare metal nodes. So they sort of pretend to be bare metal for Ironic testing purposes, but they're actually VMs, and this is the output from their console. And in fact, if you look at a more recent version of these patches, you'll see that there is an _no and C version of these. And what that is that's a patch that actually John, right here in our, or excuse me, Mr. My Gate is Broken was kind enough to write for us in DevStack Gate to clean up some of that, some of those results. So this is even now more useful than usual. So, okay, let's done look at the working one, because that's not as fun as looking at the failed ones, right? At least not for purposes of the talk. I like looking at the ones that work when I'm actually trying to get things done. So we're going to look here and see why this failure occurred. We're going to hit this, and again, remember the first step. We're going to open up the console.html, wait for the browser to finish loading, and hit the end key. And this is an interesting one. This is failing in a weird way, because as you see here, we looked at what one looks successful, and this matches that same successful of the clean OKs from all the test responses, and then all of a sudden out of nowhere you see this killed. Just killed right out of nowhere. But here's your key here, is it's got timeout on that, and then run the command. And it'll say, it says error, the main setup script by this job failed, exit code 137. So what actually happened here is a DevStack timeout. It's set up so that certain tasks aren't allowed to take over a certain period of time, and if they do, it'll just kill the job out from underneath it. So even though this was happily running test and it could have succeeded, if you remember back, I told you looking at those numbers can be real useful for letting you know why this failed. And you can see that this job took just over an hour to run, which is why it ran into the timeout. So we could dig deeper and answer the question, why did it time out, if we wanted to? And we can look here, and you can see this is real interesting. Right here, if you look at the timestamps, you see there's a whole bunch of 2150, 2150, 21, and then there's a 2111. So if you look right here, when it's doing running DevStack, it says this usually takes 10 to 15 minutes. Like I said, for Ironic Python agent, it has to do a little more. So that's not necessarily helpful here. But it did take 40 minutes. And looking at the previous ones where we had the full list of jobs, you saw that we had some jobs that were passing in less than 40 minutes overall. So clearly something happened in this DevStack run that took longer than anticipated, which caused the job to eventually time out. Now, here's the decision point. And here's the thing that I've had a lot of people mention to me that they can struggle with this. And it's sort of, how far do you go when you troubleshoot this stuff? If you see a failure like this, there is extremely, extremely low likelihood that something in your patch has caused it. So how much responsibility do you have as an OpenStack developer to troubleshoot this? And here's the case that I'll make. I think that troubleshooting a failed gate run is super useful for sort of putting your feet in the shoes of an operator for a few minutes. You get to experience what it's like to troubleshoot with the type of logging that OpenStack has or your project has. You can get an idea of some of the weak points where things can commonly fail, or maybe even find a race that's uncommon if you dig in. But even more so than that, every time the gate fails, it uses up resources that it takes to run other jobs. You can actually view some of this if you go to status.openstack.org/Zool, ZUUL, you can see some of the Zool status. And you can see right now there are 73 jobs in the check queue. If you go all the way down here to the bottom, you can see how many test nodes are being used by OpenStack at any given time. This is usually between 500 and 1,000 test nodes. They're launching over 1,000 jobs per hour. And so even a failure that happens a really small percentage of the time can end up eating up a lot of gate time and gate resources. And especially temporally at this time in the cycle, having a long line for the gate is a really pricey thing. So I strongly, strongly encourage you to take the time and do the troubleshooting when you do see a failure and figure out why something happened, because you don't want to be wasteful of those resources. And every time we can knock out a failure that happens in the gate 1% of the time, you're talking about a huge return in terms of not failing the jobs. And who knows, you might even find a bug and fix one that a deployer might find at scale that's hard for us to find in DevStack because they don't happen often. So here's the decision point, and I'm going to decide, let's look in and see why this DevStack run took a long time. Well, I got to go back here. So now I'm going to delve into the logs, and we're going to look at the DevStack log. And again, I'm going to wait for it to load. I'm going to hit the end key. And I see it worked. So I have to take a little bit different tactic than usual here because it succeeded. So there's not going to necessarily be an error at the end. But what I want to look for is the same thing I did in console.html. I want to quickly skim the timestamps and see if I can find a jump. And if I can find a jump in that timestamp, see if I can figure out why it jumped. And full disclosure, I did find that this was a DevStack timeout, but I haven't actually troubleshot why it timed out. So we can figure it out together. And you see you've got 50s. I'm going to page up a few pages. You see it's going, it's going. I'm going to go back to the top and go down, see if I can find something that's obviously failing or slow. This is a huge file, so it can take quite some time, and I will scroll it here. Y'all won't be able to see it quite as fast as I will because of the video sharing being so fast, or not so fast, really. And we're going to find what took so long here.
Jay, do you know about the line that says if it's a slow node or not?
No, I don't.
I forget if it's at the top of DevStack log or console.log, but yeah, if it's a noticeably slow node, it will log it.
I get that on almost every run now.
Well done.
Can you find out what that string is, Jim, and I'll search for it after I get to...
what patch is this? And I'll just...
This is an old patch. I'm looking at... Yeah, here, I'll paste it to you in IRC, Jim.
Yeah, I think if it takes more than 20 minutes, then DevStack will write a warning message out.
Yeah. So we're seeing, I'm going to cheat here a little bit, and I know that this is building a CoreOS image. So I'm going to Control F CoreOS. Well, where am I? Control F. And see if I can find where the CoreOS build is, because I suspect that's going to be what's actually slowing things down. And you'll find this will work a lot better for you in general when you're troubleshooting this stuff to do some searching. Okay, build IPA CoreOS RAM disk. This didn't get here until after DevStack had already been running for 30 minutes, so it's actually not even the build. I think in this case, and it's hard to put a finger on it, I would troubleshoot this further if we weren't doing this live on video. But I suspect we're looking at a situation here where something else in DevStack is causing this to be slow, or it may just be a slow node in general. I'm going to Control F slow, since Jim said that sometimes it says that. There's only 7 matches. And it's all the MySQL slow query log. Yeah.
It's in console.log. There's me and Michael linking stuff on the sidebar there in the chat window.
Yeah. Oh, right there. That's right there in that place we were looking before when it took a long time. So that's maybe something worth looking at.
I'll look into it.
So this is an example of how it can fail. And this is a failure, again, that's completely unrelated to the patch. This wasn't the final patch set of this code, which did eventually merge. But this is a change where I think a recheck super reasonable to do. Because we figured out what it was. We figured out it's a temporarily slow node, and we can continue on. Another thing that can help be peace of mind in that case is if you go back and you look at the actual patch here, there are no changes whatsoever to DevStack. All the changes are in code or build tooling. So it's not likely that this would have caused DevStack to be slower anyway. That doesn't mean you're absolved of responsibility for figuring out why it failed, but it does mean that you know it wasn't your code. So you can sort of time box yourself or whatever you find necessary. So let's look at another example. This one is a grenade failure. This is actually an active failure in the ironic gate right now. If you go look at the whiteboard, knock on wood, unless someone fixed it in the last 2 hours, you'll see that this failure is up here. And I'm going to show you how to look at this because finding a failure in grenade is often a little bit different than finding a failure in normal DevStack. For those who aren't familiar with grenade, what generally happens with grenade is you spin up an environment on the previous stable release. So in this case, this is on master of ironic running grenade. So that means that it's going to install Newton, and then it's going to run a set of tests. It's going to upgrade Newton to Okada, or well, not Okada, but to master, which is, sort of acting as Okada until we're done. It'll upgrade it to master and then rerun the set of tests. So a grenade job failing is an important thing to look at because you don't want to break upgrades for our deployers. And upgrades are something that OpenStack's been traditionally bad at. So, try to break the stereotype by making our upgrades better. So we're going to click on this again, the exact same thing as before, but I will point out something. Because this is a grenade job, you only get the help text in here if it's a Tempest run. So you see there's no helpful text here. So if you forget what a log means or what a log belongs to, you can go and load up one of the Tempest jobs and get that help text back, or just look it straight up out of the repo in DevStack Gate. So let's do what we always do. Console.html, once it finishes loading, hit the end key. And you can see here, error, the main setup script run by this job failed exit code 1. And you can see that, you can scroll up and see what the test was it was running right here, just grenade.sh. So grenade failed starting up. This is also the error, in the general error you would receive if DevStack failed to set up. Because DevStack is considered the setup job for most of our Gate jobs, but Grenade runs the setup stuff for Grenade jobs. So we're going to look at grenade.sh and see why this failed. So we're going to go back, go to logs, and load up grenade.sh.txt. And we'll click on it again. There we go. Great. So here, we're going to follow the same pattern. Wait for it to load, hit the end key, and go from the bottom up, except for I didn't wait for it to load. So I got to wait more. This is a huge file. Okay, great. So in this case, we see the very first thing we see is exit code 1. So we know that it failed here, and we can go up and we can see error failure in Nova upgrade.sh. Now, I feel a little bit bad for the person who had to troubleshoot this initially, because this, in terms of how things fail, is one of the harder ones to troubleshoot, because what's happening in this case is actually a race between Nova's upgrade and Ironic's upgrade that was exposed via a recent DevStack change. So it's a little bit tough one to troubleshoot, but you can see here, we go to grenade.sh, we look at it, we find the error, and we see this. But there's a couple of things I want to point out about troubleshooting grenade that are a little bit different than troubleshooting other stuff that aren't necessarily relevant to this failure. You see that we don't have the various screen logs here, the screen Nova scheduler, the screen IR API, all that stuff. But that's because we have them segmented into the old which is the previous stable, in this case Newton, versus the new. So you can hit old, and you can look here, and you see you have all the logs from the initial setup of Grenade that it did on stable, and this passed all the tests. So we can look at these logs if we want, but there's most likely not going to be anything useful here because we saw that the script that failed was run out of the new directory. So we're going to go to new, and this is going to be the master version. And it said that the computer failed to start, so we can look at this in-CPU log here, and you can see you've got the logs. Now, this is the first time we've loaded up an OpenStack log in here, and I'm not going to really cover how to troubleshoot your particular service you work on using logs. It's one of those things where you should be able to read the logs, compare them to the code, and figure out what's going on. And if, as I suggested earlier, you've taken a look at what all the logs look like for a job that's completely passing, you will have an idea, especially the more and more you do it, of what belongs versus what doesn't. But there are a few really nice tricks they have in here to help you go through it. One is that you can look at just logs that are error by hitting the error button at the top, and it filters to all the error ones. And in this case, you can see that almost immediately we know what the failure is here. And it looks like perhaps that Nova Compute is trying to talk to Ironic before the new Ironic has registered itself into Keystone, which matches the bug and everything in the whiteboard. Like I said, this is cheating. I was able to look up after the fact what broke and work backward. But you can also hit warning, get the warnings as well, and also on. So you can look at all these. Another neat trick that you can do when you're troubleshooting this is, let's say you wanted someone's help. If you look over here, that's an underline. This is actually a link that I'm hovering on, and you can click it, and it'll highlight the timestamp and also put the timestamp in your URL. So that way you can copy and paste that URL out with a timestamp to someone else who's maybe helping you troubleshoot. That makes sense? And this works in DevStack, it works in Grenade, it works everywhere. So this is sort of the end of what I have planned. I wanted to sort of give you a tour through what's available in the gate, you know, some general troubleshooting steps to sort of start from the infrastructure first, from the console, work your way to the more specific bits until kind of you get all the way back to the code, right? You make sure that, you know, DevStack or Grenade set up properly, you check all of that stuff, and then once you can find the error that failed, you can then go back and trace why it failed by looking at your OpenStack service logs. There are a couple other tricks that, given the sort of collection of failed jobs I found, I didn't get a chance to show you yet, and so I will now. If you have a test and you've seen it's failed a Tempest test, you can fish through the logs to try to find it, or you can hit right here, this teststar results.html.gz. In this case, you see it's all green because none of the Tempest tests failed here. But if one did fail, you could hit detail there and see specifically details about how it failed. It would print the trace back, etc., which can often be a lot easier to grok than trying to fish those same results out of console.html. So at the very beginning of this talk, I invited anyone who had a pet failure that they wanted looked at to bring it up. If you've got one of those, feel free to bring it up. If you've got a general question, you can go ahead and ask it as well, and I'll take your questions.
Just as a note for Ironic people on Grenade jobs, we have a thing called Ironic-BM-logs. They're the bare metal virtual machine logs, and those will only be in the old directory. All of them will be in the old directory, new and old, I think. They're definitely not in the new directory, so I think I believe they're all in the old directory.
Oh, well, today I learned that might even be worth a bug to enhance that to make it where it puts the ones after it's upgraded into a different directory, but I know that might not be so easy because of the way it hooks in.
Yeah, you have to update DevStack Gate.
Which I had no idea how it worked until I read your patch, so thanks for that no ANSI patch because it taught me how that worked as well. Were there any other questions that anyone had about troubleshooting the gate or anything else? Going twice. Sold. Great.
Someone posted on the group chat.
Yeah, I will share that with the group here. It's nice enough to give us an example with a failing Tempest test and what that looks like in the tester results. So you can see here with the tester results, you've got the fail. You can hit detail to see more detail about that test. Click fail to see the failure. And Tempest will log the full thing, the response, the request, all that, as well as exactly why it errored. You can see in this case it says SSH timed out to the node. And that is in comparison to, if you go, well, let's see, I'm going to trace it back from here. There we go. No idea what the shortcut is in Mac to go to the end of line. There you go. So if you look at the console.html in this case, and you go to the bottom, you can often see that getting the failing job out of here, the failing Tempest test out of here, can sometimes be a pain because you have to scroll and scroll and scroll and scroll and scroll to find it. Yeah, see, hard to find, it's missing, difficult. Instead, you go to the tester results and you get it right in front of your face, which is really useful and helps you immediately start pinpointing your troubleshooting. Because that's really what we're talking about, right? When we're talking about gate troubleshooting skills, I think we're all smart enough people and have had to explore things enough to dig around, click on things until we find what's wrong. But what you can do is by using some of the strategies presented to look at the console first, look at the infrastructure, and then look at the service and why it failed, you can limit the amount of time gate troubleshooting and narrow your focus quickly. Were there any other questions or comments? All right. Well, thank you for coming. I'm going to stop.